Hi everyone, welcome back to Engineer Easy. Last time we learned what an operating system is. Today we start chapter 2, a topic that confuses many students, process versus program. Watch till the end, you will never mix these two up again. What is a program? Let's start simple. Think about a cookbook on your kitchen shelf. It has clear steps. Boil the pasta, heat the oil, add garlic, but right now no one is cooking. It is just sitting there, quiet as words on a page. This is what a program is. A program is a fixed set of instructions written to do a task. It stays on storage, your disk or SSD, by itself. It does nothing. It just waits until someone uses it. Remember this key point. A program is just a stored file. It does not use any CPU or memory while it is sitting idle. So think of it this way, that recipe book on your shelf is your program. No one is using gas or ingredients just because the book exists. Now think about a chef opening that recipe book and actually cooking. The stove stands on, the pan gets hot, real ingredients are being used right now. This is a process. A process is a program that is currently running. It becomes active the moment the OS loads and runs it, and it uses real resources like CPU, memory, and input output. So remember, program is the recipe, process is the chef actually cooking it right now. Program versus process side by side. Let's compare them clearly. Program is a passive. It stays on disk, doesn't use CPU or RAM when idle, and stays there until you delete it. For example, a game.exe file sitting in your folder. Next is process. So process is a active, is loaded into memory, needs CPU and RAM while running, and only lets until it finishes. Same example, but now that game.exe is actually running on your screen. Easy way to remember recipe versus shape. One is a stored plan, the other is that plan actually happening. One program, many processes. Here is something interesting that confuses many students in exams. Think about WhatsApp. There is only one WhatsApp program installed on your phone, one set of code that everyone shares. But now imagine there of your friends open WhatsApp on their own phones at the same time. That one program is now running as the three separate processes, each with its own memory space, its own state, and its own resources. So the big point here, the same program can run as many processes at the same time as long as the OS and hardware allow it. One recipe, but three shapes. cooking it in three different kitchens at the same time. Process anatomy. What the OS tracks. Now let's go a bit deeper. What does the OS actually keep track of for each running process? First, the process ID, PID, and its parent PID, so the OS knows actu- exactly which process is which. Second one is the program counter and CPU registers. This tells the OS exactly where the process is in its execution. Third one is the memory layout. Code, heap, stack, and data all placed in the memory. Fourth one is open file, sockets, and input output. Anything the process is using to talk to the outside world. And fifth, the process state. Whether it is ready, running, blocked, or finished. Think of this like a status board in a busy kitchen. The head chef needs to know exactly which cook is doing what and at what stage each dish is. Quick comparison. Let's put this into one simple table for revision. Nature. Program is passive. Process is active. Storage. Program stays on disk. Process is loaded in RAM. Lifespan. Program stays forever until deleted. Process only lasts until it finishing running. Resources. Program needs none when idle. Process needs CPU, memory, and input output. Classic example. Game.exe file is the program. Game.exe actually running is the process. Why these distinctions matter? You might ask, why does this even matter for your exam and beyond? Because the idea is the foundation for three big OS topics you will study next. Memory management. How the OS gives memory to different processes and keeps them separate so they don't interfere with each other. CPU scheduling. How the OS shares CPU time fairly between many processes so your system stays smooth and responsive. And resource control. How files input output access and permissions are given and limited to each process for safety and stability. Everything you study next builds on this one idea, so this is not just a definition to memorize, it's a real foundation. Quick recap. Let's put it all together. Program, the passive stored recipe written in code. Process, the active chef actually running that program right now. Multiple process. One single program can create many processes at the same time, each one tracked separately by the OS, just like our WhatsApp example. In one line, the program is the stored recipe. The process is the chef cooking it right now, using CPU, memory, and input output. And one program can create many separate processes at once. That's it for today's class. If these examples made things click for you, hit the like button, subscribe to Engineer Easy, and share this with a classmate who is still confused process and program. In our next video, we are covering process dates and the program control block or PCB, which builds directly on everything we just learned today. Drop a comment telling me your university and course. It genuinely helps me shape future video around what you actually need. See you in the next class. Keep learning.